Hi guys, I hope you guys are good. What I'm going to do here is I'm going to try and basically sum up everything that you guys are going to be doing in your paper 2 in grade 10. So I'm going to try and sum up everything in just in notes, and I hope this really helps you study for your final exams. Right. Now I'm going to start with the midpoint theorem. So in the midpoint theorem, basically you see that I have drawn this type of a triangle. Now, the most important thing is that you must remember that if this here is A, this is B, and this is C, let's call that E and F. The most important thing is to know that this is a midpoint and also this is a midpoint. Right, to try and just clearly explain that is, the midpoint theorem says that if I have a triangle, right, I have a triangle. It's very important. This happens in a triangle. And let's call that triangle A, B, C as well. If I have that triangle and I have a line that is drawn at the midpoint of AB, please understand that I'm drawing the line in the midpoint of AB. And that line will be attached to the midpoint of AC. So understand, I'm drawing the line at the midpoint of AB to the midpoint of AC. So the midpoint theorem says that if a line is drawn at the midpoint of AB to the midpoint of AC, automatically that means that that line will be parallel to BC. Hence I said let's call this line EF. So remember, I had a triangle and then I drew a line at the midpoint, in other words in point E. Point E is now a midpoint. I drew a line at midpoint of AB, point E, to the midpoint of AC, and then we call that point F. F is a midpoint, E is a midpoint. So the midpoint theorem says that if I have a line that is drawn at the midpoint of AB to the midpoint of AC, automatically that means that EF is parallel to BC. Okay, let's try that again one last time. I'm going to change the color there. Try that one last time. Right, we have a triangle. Triangle is called A, B, C. We draw a midpoint there, another midpoint there. So this E is the midpoint of AB, and this is F, the midpoint of AC. Now it says a line drawn at the midpoint of one side to the second side. Basically, that means EF is now parallel to BC. And this is called the midpoint theorem, guys. That's very, very important. Right. Now, so that means AE is equals to BE, right? Because it's a midpoint, so automatically it means the distance of AE is equal to the distance of BE. And then if we look at the other side, that means the distance of AF is equal to the distance of FC. Okay, so that is what you basically need to keep in your mind, right? Whenever you're dealing with the midpoint theorem. So that is very, very, very important, guys. You don't just draw lines and assume things. We have to make sure that we draw the line at the midpoint. So now, but let's go to the definition of the midpoint theorem and just try to understand what it says. The definition of the midpoint theorem says that the midpoint theorem states that the line segment connecting two midpoints of a triangle is parallel to the third side and half the length of the third side. All right, exactly what we said. A line segment that is joining two midpoints. So you see this line, it's joining E and F because those are what? They are two midpoints. A line segment joining two midpoints, it means that that line is going to be parallel to the third side. So this is the third side that they're talking about. But more to that, then they say what now? They say that this line EF, its length is going to be the uh, half the length of BC. What does that mean? It means that EF is equals to BC divided by 2. So sometimes you can write this as EF is equals to 1 over 2 BC. But if you check now, what exactly does that mean if they tell us that EF is half BC? It means that EF, or let's say this, BC is equals to 2 EF. In other words, if the length of EF was 2, the length of BC would be 4. Okay? Right. Now let's try to play with this and see where that takes us. Let's try to just play with it. Let's say we have a triangle like this. Let's say we had a triangle like this. We have a triangle there. Oh, sorry, that's so horrible. We have a triangle there. This is A, this is B, and this is C. And then we say same thing. This is E, this is F. And then let's say you are given this length here is maybe 2y plus 1, right? So if the length of EF is 2y plus 1, what is the length of BC going to be? The length of BC will be 2 times 2y plus 1. I hope you get what we mean there. Because now remember, if we take this length here of EF and multiply it by 2, we must get the length of what? The length of BC. Now same thing here. The length of EF was 2 here, right? In that red triangle, the length of EF was 2, and the length of BC will be 4. Basically 2 times 2, which will give us 4. Okay, right. So now we'll have what? We'll have 2y plus 1, which is the length of EF. And then 4y plus 2 will give us the length of what? The length of BC. Okay, right. So now this is the length of EF in terms of y. This is the length of BC in terms of y. So now basically there's about a couple of things we need to consider. For you to be able to use the midpoint theorem, a line must be drawn connecting the midpoint of AB with the midpoint of AC. If that line is drawn and it's connecting both the midpoints, automatically means that this line is parallel to this one, which now takes us maybe back to grade 10. What does that mean? If these lines are what? If these lines are parallel, let me change the color there. If these lines EF is parallel to BC, automatically what does it mean? This angle is equals to this angle. Corresponding angles, I don't know if you remember that. And this line here is equals to this line over here. Alright, still corresponding angles. So that, what does that mean? That means you can also use this as co-interior. I don't know how that helps you, but I'm just showing you the connection in between the midpoint theorem and everything that you've learned from the lower grades. Okay, so basically that is that. So you have to have a grasp of such things for you to be able to use the midpoint theorem. But the midpoint theorem also has something called the converse midpoint theorem. Okay, so the converse midpoint theorem basically says that, okay, we are now using the opposite. Remember, in our midpoint theorem, what did we say? We said we have a line segment that is joining two midpoints, right? And that line segment is going to be parallel to the third side, okay? And also, that means that that line, the length of that line segment is going to be half of the length of the third side. Easy, it means that EF is half BC. In other words, BC is twice EF, right? Okay, fine. So that's what the midpoint theorem says. And then now let us look at the converse midpoint theorem. Or before we go to the converse midpoint theorem, let us just write the midpoint theorem in words. Let's write it in words so that you try to understand. A line segment joining two midpoints, right, is parallel to the third side, and its length is half that of the third side. Okay. Right, the line segment joining two midpoints is parallel to the third side, and its length is half that of the third side. So basically what I have tried to explain for you there. So that is basically the midpoint theorem. Like I said, you know, you can play around it. There's a lot of things that you can do when it comes to midpoint theorem, but I'm just trying to make you understand what the midpoint theorem is. Okay, right. And then we go to the converse midpoint theorem, and then we try to like understand what is happening with the converse midpoint theorem. Let me just try to get rid of that. Okay, right. So the converse midpoint theorem says that we have a triangle still, right? That is so horrible. That is so bad. Let me fix it. Let me fix it. We have a triangle, right? We have a triangle, and in this triangle, let's call it A, let's call this B, let's call this C, right? And then you have a midpoint. The midpoint, you must be aware that the midpoint is in between AB, or is in AB, right? So automatically that means that this is now the midpoint. The length of A, what can we call that? Let's call E again. The length of AE is the same as the length of BE, right? So it says if you have a midpoint and then you have a line, right, that is going to the other side, right? And then you are then told that this is parallel to that. Let's call this F again. So basically you have a line drawn at the midpoint of AB to AC, right? In this case, we are not joining two midpoints. That's not what is happening in converse midpoint theorem. You are not joining two midpoints. Let me just underline that so that you guys don't confuse the two, right? So you are not joining two midpoints. You are basically joining the point E with the point F. Okay, right. So as we are joining point E with the point F, now you are only told that E is a midpoint, and then you are told that EF is parallel to BC. So the converse midpoint theorem says that if you have a line drawn at the midpoint to the second side, AC is the second side, you have a line segment that is drawn from the midpoint of AB to the second side, and that line is parallel to BC, automatically that means that F is the midpoint of AC. I hope you guys get what I'm trying to say here, right? In the midpoint theorem, remember, in the midpoint theorem, we said a line segment is joining two midpoints, right? So since that line segment is joining two midpoints, automatically it means that the line segment is parallel to the third side, and its length is half that of the third side. But in converse midpoint theorem, we're saying that you have a line segment drawn at the midpoint of one side. In this case, that side is AB, right? And the midpoint is E. To the second side is AC. Nothing has been said about F being the midpoint of AC just yet. The only things that you know and the only things that you have is E is the midpoint of AB. Line segment is drawn to the other side, right, AC. But the second information that you have is that EF is parallel to BC, right? So now obviously what that means is that it means that then F will be a midpoint. That's what the converse midpoint theorem says. So in this case, you do not have two midpoints joined by a line segment. You have a line segment drawn from the midpoint of one side to the other side, and then you're also told that EF is parallel to BC, right? So how can you put this neatly? You can say this: if a line is drawn through the midpoint of one side of a triangle and is parallel to another side, it will bisect the third side. When you say bisect, you mean that the third side will be cut into two equal parts. Okay, right. If that is too much, we'll try to simplify it. Let's just put it like this: a line segment, drawn, oh no, let me fix that. Just a second, let me just try to fix that, because wow, because that doesn't look good at all. It doesn't look good at all. Right, a line segment drawn at the midpoint of one side and is parallel to the third side, right, will I don't know why this one is slow. Will bisect the second side. Will bisect the second side at the very slow at the midpoint. Right, bear with me because this thing is responding very slow. Right, and this is your converse, guys. It's your converse. This is your converse midpoint. You see now, this thing is very, very slow. The converse midpoint. Just trying to rush to finish because wow. Yeah, basically that is that. So yeah, I hope that helps. But with the midpoint theorem, you guys must try to use whatever they told you or whatever we spoke about in this segment, and try to apply that to your practice questions, which is going to be very challenging. But yeah, I hope that helps.